Okay, we're moving on to section 8.4. It's the section that has some proofs in this chapter. Don't worry, the proofs are pretty easy, as you'll see. So let's get to introducing a couple of the theorems first. So there's three main theorems initially. The first one is AA similarity. And so basically, if you have two angles of a triangle congruent to two corresponding angles of a second triangle, then the triangles are similar. And you can go ahead and just write AA similarity. Please use reference numbers like we did in some of the previous, obviously all the previous proofs we're doing with the congruent triangles. Okay? SSS is basically if the ratios of the corresponding sides triangles are equal, then the triangles are similar. And again, you can use SSS similarity. And then for SAS, if the ratios of two corresponding sides are equal and the included angles, the angles that are sandwiched between the two sides, are congruent, then the triangles are similar. And again, you can write SAS similarity like that. Okay, I will say that most of the time, like 98.6% of the time, I'm totally making that up, but most of the time, it's going to be this one. It's going to be AA similarity. Okay, so let's take a look at our first proof down here. So this proof says it's given that these are perpendicular, so that's a right angle here, it's perpendicular, it's a right angle there. And that's it, that's all it says. And then it says prove that this triangle is similar to the entire triangle, so the big triangle. Okay, and so step one is given. Step two, hopefully you can see that you have right angles there. So angle EBA and angle DCA are right angles. And then you can say that the right angles are congruent to each other because you need to have two set of angles that are congruent to each other. And you need a second set of angles that are congruent, right? In order to do AA similarity, which is the majority of the proofs are that. And so you can hopefully see that you've got a reflexive angle here, so angle A is congruent to itself. And in step 5, I can say that the triangles are similar by AA similarity from steps 3 and 4. You could have also done something like this if you wanted to. You could have said that corresponding angles are congruent, which gives you parallel sides, which gives you these corresponding angles congruent to each other, if you wanted to. But you just need two of them, and we took the easier second set of angles that are congruent. All right, let's flip over to the backside and try some more. So here we are on the backside. We're trying another one. We got a parallelogram to start out. So that gives us a whole bunch of information, obviously. and basically you're trying to prove that this triangle right here is similar to this triangle right here. Okay, so we need to, it's probably going to be AA. We need to, we have one set of angles for sure, congruent. And it looks like I can do something like this. I have, these lines are parallel because it's a parallelogram, and then I can do these angles congruent, alternate interior angles, or I could have done these angles congruent, same thing, alternate interior angles. So let's try this proof. So step 1, parallelogram. Step 2, I can say that TR is parallel to PQ. If you have a parallelogram, then opposite sides are parallel. Step 3, let's go with angle R is congruent to angle QPR because they're alternate interior angles. And then step 4, I can say that angle CSR is congruent to angle QSP because vertical angles are congruent. And that gives me an A here and an A here, so I got angle-angle similarity. So I can say that these triangles are similar by AA similarity from steps 3 and 4. Now, just like in chapters where we're proving triangles congruent, there is something similar to doing CP-CTC. So once we prove the triangles are similar, we can now go and say a couple of things because of that. So the first thing you can say is that corresponding sides of similar triangles are, what does the P stand for? Proportional. And CASTC, which you'll use a lot less, corresponding angles of similar triangles are congruent. And the reason you'll use that a lot less is because most of the time we're already proving the triangles congruent using the angles being congruent, or the triangles similar using the congruent angles, and so you really don't need to prove any more angles congruent. So most of the time it's going to be this one right here. Okay, so let's try a proof here. So it's given that HJK is a right angle. So we got this as a right angle. JM is an altitude, so that's a right angle. And you're trying to prove this. So that's what you're going to see on the proof statement when you're using the CSSTP, the corresponding sides being proportional. Okay, so let's take a look at this. It looks like you're going to start out and you have to kind of figure out which triangles are going to be similar to give you this. And it looks to me like it's going to be triangle JMK and triangle HJK. So the big triangle and this bottom triangle down here, with angle K being reflexive. Okay, and the way I got that was I basically looked at these letters here. I got the JM and the MK, and I got the HJ and the JK, and I'm looking at which triangles those sides are part of. So I start out with this. That's my givens. Step 2, looks like I can say that angle JMK is a right angle. Altitude is going to give you right angles. Now I can say that the right angles are congruent to each other. HJK is congruent to angle JMK. And I said before that angle K is congruent to itself. That's reflexive. And now I can say that the triangles are similar. So triangle JMK is similar to triangle HJK because of, again, the angle similarity. So steps 3 and 4. And now, as a follow-up, sort of as a CP-CTC step, I can do JM is to MK as HJ is to JK. Okay, and so that's step 6 there. CSSTP. And then one more thing that pops up, and I just want to point this out, is sometimes for the proof statement, it'll say instead that JM times JK is equal to MK times HJ, like this. And so if I wanted to take it that one more step further, what I've basically done here is, you think back to the beginning of this chapter, I am cross-multiplying, or doing the means, extremes, products theorem. And I had mentioned earlier in the chapter that we'd be using this abbreviation, so that's where you would use that abbreviation within a proof. Okay, let's go to the next page. Okay, one more proof here, and in this proof here, starts out by saying that these lines are parallel. This is parallel to this. And you want to prove that WS times XY is equal to XS times WZ. And I have to kind of work backwards and think about this. This is going to come from this, right? WS is to WZ as XS is to XY. Okay, and that is going to be a CSSTP working from this triangle being similar to this triangle right there. Okay, so let's get these triangles similar. So step 1, you got parallel lines. Step 2, I can say that this angle is congruent to this angle. So angle SWZ is congruent to angle SXY. I can also say that this one's congruent to this one. So angle SZW is congruent to angle Y. That's because of their corresponding angles. And they're congruent. I could have, of course, also used reflexive down here with the S, since they are shared between both those triangles. But now I can say, because I have an angle and angle, so I can do angle-angle similarity. So triangle SWZ is similar to triangle SXY by angle-angle similarity from step 2. And now, step 4, I can do this thing right here. That's going to be a CSSTP. Corresponding sides of similar triangles are proportional. And then now I can say that this is true in step 5, because because of MEPT, means extremes products theorem. And that's it. I think I'm going to stop here and let you try some proofs on your own. All right, good luck with them.